And welcome again. We're working on 13.4 today, which talks about log and exponential equations. So we'll be working through equations both for logs and exponentials. Now, before I proceed, what I'll do is, so basically we have two topics, right? I'll give you about 3 to 4 examples of each topic, and that will be it for the video. But before we move on, I need to remind you about the log properties again, properties of logs, because without those, we are going to get nowhere. The first one, which was discussed in the last lesson, 13.3, is the multiplication property, which says that if you are doing log of a product, mn, m times n, and we can call it base b, that is the same as the sum of the individual log m base a and log n base a. Number two was the division property, which said if we are taking the log of a quotient, m divided by n, let's say this also has base b, then that is the same as the difference of the individual logs. Log of m come first, and the numerator comes first, keep in mind same base, minus log of the denominator with the same base. And the third property we did was the power property, that if we are taking log of something raised to the power of r, then that is the same as the product of the power and then the log itself. So basically this power can be brought in the very front here and then multiplied with the rest of the log. And backwards as well. If there's already a power, if there's a number sitting here, that means we can take it up here and make it the power of the log. Based off of 3, we should be able to solve these equations, but we do need some basic algebra solving equation skills. So topic 1, let's solve log equations, or logarithmic equations. All right, here's an example 1. Whoopsies. 2 log x, okay, base is 5, equals log of 9 with the same base 5. Okay, here's an equation in front of me, and it's a log equation because I have log on both sides. Now notice how the log is the same, it's still log, and also they have the same base, which is a good thing because I can only compare apple to apples, right? I can't compare two different fruits. For example, if I have, change the color, let's say I have natural log to of x minus 3, and let's say that equals regular log of 5, let's say. Now this is, I'm not comparing apples to apples because this is natural log and this is regular log. Again, if you've forgotten what those two are, let me quickly explain that as well. Natural log is nothing but log to the base e of whatever. And then log, if it's just written as log, then that is automatically log of whatever to the base 10. Anything else, we will have a log number which is different from 10 or e. Okay, and so hence I say that this is log base 5, this is also log base 5. So I can compare apples to apples. However, there's a 2 sitting here in the very front. So I need to get rid of that 2. And to be able to get rid of the 2, I'm actually going to use the third property. This is up here in the front. I can move it as the power of the log. So log x squared base 5 is equal to log 9 base 5. And now I can compare the two sides. It's literally log base 5 of x squared equals log base 5 of 9, and hence these two must be equal. X squared must equal 9, right? And now I have a new equation. Now algebra takes over. Can I solve this teeny little equation? I will have to square root both sides, right? And x turns out to be 3. Don't forget the other answer, or negative 3. However, one of these answers is extraneous, so I'll have to ignore this answer. Why is this extraneous? Basic log or parent log function, let's say if this is exponential, then log is the inverse of exponential. So log function would be, let's say this pink one, which will go like that, right? And then the blue line, which is the y-axis, it acts as the asymptote, and hence if you focus on this log function, all the x values are going to stay positive because this function is not going, it's not hopping to any of these quadrants unless we have transformations. I'll get to one of those examples as well. But because this is simple log, there's no transformation involved. X is x. It's not x minus 5 and other stuff added or subtracted from it, because when you subtract or add something from x, that is responsible for horizontal shift. And when we add or subtract the number at the very end of any function, and that's responsible for vertical shift. Because this particular one doesn't have any, the domain and range is very similar, or yeah, it's very similar to the parent log, which is this pink one. And then you can see x values are not going to be negative, and hence I'm going to ignore that answer. And I have found the value of x, which is what this question is asking, find x. So that example is done. We were wanting to find x and we found it. It's going to build up from here pretty soon. Um, let me give you one more example, something similar. Let's say example 2. Log of 4 base 3 equals 2 log of x base 3. And I have to solve this equation. It is a log equation. The only thing unknown in here is the x. So obviously I'm working on this equation to be able to find x. Now both are base 3's and both of them are log type of logs, except for that little 2. So I need to make sure that the format of both sides of the equation is the exact same before I start comparing them. And hence I'm going to use the same property. This 2 can actually be raised up there as the power of log using the third property of log. And hence this can be written as base 3x squared, right? Now everything is exactly same. Hence, whatever is after the log here must equal whatever is after the log here. So 4 must equal x squared for this to be true. And from here, algebra takes over, square root both sides, square root, x equals 2 or negative 2. And again, because this is simple x, there are no transformations involved, I'll have to ignore this answer, and the only answer is x must equal 2, the only possible answer. So this was a very similar example to the first one. Okay, let's build up on it. Here's a longer equation. Log of x plus 6, and now you can see transformations are going on. Base 5, to that we have added log of x plus 2 to base 5 must equal 1. And I have to solve this equation. Again, what am I trying to find? X. So before I move on with this, I have to see what must the answers be equal to. Like, what is the domain of this? I can't just accept any possible answer. Now, because this is not just x, it's actually x plus 3 and x plus 2 involved. So on the side, I take that x plus 3 and I say that the domain has to be positive. So this must be greater than 0. And at the same time, the x plus 2 must also be greater than 0. Those are the restrictions on the domain, hence restrictions on my answer. Why do I say domain? Because x is the domain. A quick solving here, subtract 6 from both sides, so x must be greater than negative 6. And at the same time, subtract negative 2 from this inequality, and then x is greater than negative 2. So these are the restrictions. X must be greater than negative 6. On a number line, negative 6 is here, negative 2 is somewhere here. I have to satisfy both of them. The equation has to satisfy both of them. Greater than negative 6 means in this direction, and greater than negative 2 means in that direction as well. So what are the overlapping area? Negative 2 onwards, and hence domain is going to be anything greater than negative 2, which means the answer better be greater than negative 2. Now you can do this beforehand to find your domain restrictions, or you can do it after finding the answer to see if both the answers or 3 answers or how many answers we get are acceptable or not. Now the question is, how do I even proceed with this? Log base 5, both are the same. And I do see there's this addition going on there. And addition reminds me that I can compress this problem using property number 1. You see addition, that this format has been given to me, and I can actually work it out backwards and compress the property as the product property. Let's do that. So this looks like log of whatever base m plus log of whatever same base n can be rewritten as the log of the product of the two, m times n. Now this is your m and this is your n. So let's combine it. Log base 5 m times n equals 1. So I kind of continued from there. Now that I combined it, a little bit of algebra kicks in here because these two can be multiplied using FOIL or however you want to multiply it. So I'm going to multiply these binomials. X times x is x squared plus 2x plus 6x, which is 8x. And then the last to last, 6 times 2 is 12 equals 1, right? There was 1 on the other hand side. All right, it's like, where do I go from here? Now this needs to be reread as an exponential problem. What did we learn in the very beginning of logs? How do we define logs? Let's say we have 2 to the power of x equals y. How could I rewrite this exponential as log? The very basic definition. Log to the base 2 of y equals x, where the input of an exponential problem is actually the output of the log problem, or the exponential to the exponential problem, or the exponent to the exponential problem is the answer to the log problem. And if I were given this, I could have gone backwards. So I've been given this, and I've been given log, and I'm going to rewrite this into an exponential problem based on the definition of log and exponential problem. Base, remember, start here, go to the right side of the equation, and then come back here. So 5 raised to the first power must equal this whole thing, which is a trinomial, x squared plus 8x plus 12. And just being able to go from here to here requires the basic understanding of converting from exponential to log and logs to exponential. 5 to the first power is 5. I really don't have to write that one. And then algebra takes over from here. Subtract 5 from both sides. And I'm trying to, so I subtracted 5 from both sides. Now I have this trinomial. To be able to do this, I need to be able to factor it out. If you remember, x. And then I'm looking at factors of 7, which when added or subtracted will give me 8. From algebra 1 again. Factors of 7, which when added or subtracted will give me 8. Has to be 7 and 1, right? Because 7 times 1 is 7, and 7 plus 1 is 8. So it's 7 and 1. It's plus 7, and x plus 1 equals 0. Which means the product of x plus 7 and x plus 1 equals 0, that I can split here, which means either x plus 7 equals 0 or x plus 1 equals 0. Subtract 7 from both sides and subtract 1 from both sides. Okay, we ended up getting 2 answers. Now is the time to look at our domain restrictions. Well, domain has to be greater than -2. Which one of these is greater than -2? -7 is less than -2, and hence we're going to ignore that answer. And this is our final answer. I know, it was very interesting and different and unique. You've never done this before. Let me give you another example. Hopefully this one's slightly not as long. So natural log of x plus natural log of x minus 4, they're saying, equals natural log of x plus 6. And I have to solve this log equation. They all have natural logs, which is good. And again, remember, natural log is nothing but log to the base e, where e is a special constant number, 2.71, and goes on forever. It's an irrational number. So I'm like, how do I compress it? I have to find x, obviously. And all I have is those 3 properties. And I see this plus sign. Both are natural logs. I should be able to compress it, just like in the previous question. The sum of logs can be written as the product of the individual logs. And this is your m, this is the n. I could rewrite it as natural log of m times n, which is what I did. equals natural log of x plus 6. And if you look at it now, this is like perfectly laid out. So natural log of something equals natural log of something else. So that something and something else must equal each other. So this must equal that for this to be true. Hence, x times x minus 4 equals x plus 6. And log goes away because I don't need that log anymore. I'm comparing left-hand side to right-hand side. This must be true then, what I wrote in white. From here, algebra takes over. I'm going to distribute the x. Subtract x from both sides because those two are like terms. X squared minus 5x equals 6. Also subtract 6 from both sides equals 0. And I end up with a trinomial just like the one here. I need to factor it out. I'm looking for factors of negative 6, which when added subtracted will give me negative 5. That should be negative 5 and no, negative 6 and 1, correct? When I multiply those two, I get negative 6. When I add those two, I get negative 5. So here's the factoring and x minus 1, which means either x minus 6 equals 0 or x minus 1 equals 0. One of them have to. Add 6 to both sides, add 1 to both sides. And in this question, I did it backwards. Like I got two answers. Now I'm going to see what are the restrictions to the domain. So the restrictions come from what's after the log. X has to be greater than 0. The next one also has to be greater than 0. And this last one also has to be greater than 0. From here, I get x must be greater than 4. Well, this is solved as much as it could be. Here's the second restriction, and x must be greater than negative 6. Third restriction. So on number line, if this is 0, has to be greater than 0. 4 is somewhere here, so it has to be greater than 4. And then negative 6 is somewhere here, so it has to be greater than negative 6. So the overlapping parts are greater than 4. Right? And hence, I'm going to ignore that answer, x equals 6. All right, going backwards now, I showed you 4 examples of solving log equations. Topic 2 and the last one is solving exponential equations. Example 1, all I have is 3 to the power of x equals 7. A small little exponential equation. It's exponential because the domain or the x is acting as an exponent itself. Now, if I think about it a little bit, 3 to the first power is 3. 3 to the second power jumps straight to 9. And I'm looking at 7. So it's somewhere in between 3 and 9, but more closer to 7, which means the answer is between 1 and 2. Does that make sense? Between 1 and 2, however, probably a little more closer to 2, I guess. So I just got an idea of the answer, nothing else so far. How do I solve the equation? We're going to use logs here. I'm going to go ahead and log both sides. I'm going to get the natural log or regular log, doesn't matter. So I'm going to take the log of left-hand side. If I take the log of one side, I have to take the log of the other side as well, because there's no other way to solve it. Once I have this, keep in mind, we're trying to find x. That's the goal. I see this exponent. I can use that third property of log and bring that exponent actually in the front here. Natural log 3, natural log of 7. Keep in mind, I'm still trying to find x. I'm getting there. If I can get rid of this log of 3, I will have x by itself. Because x and natural log 3 are being multiplied, we'll have to divide both sides by natural log of 3. Log of 3. So x equals the quotient of natural log of 3 and natural log of 7. Backwards, I said it backwards. Now that is something we can't do, so we'll need calculator. Natural log is under miscellaneous. 7 divided by the log 3. 1.77 and so on. Let's round it to 3 places, so 1.771. X equals 1.771 approximately. And you see, when I was analyzing it, I knew the answer was between 1 and 2, and I can quickly check that, yes, this looks good. But maybe you would have found this one slightly easier than solving log equations. Here's another one, very simple to the first, or very similar to the first one. The exact same concept, I'm trying to find x. If I logically think through it, first power is 2, second power is 4, 2 to the third power is 8, and I'm looking at 5, so the answer will be between 2 and 3. And the best way to get started with this will be to take log of both sides, and you can take natural log or any other log. Now I'm going to use the same third property that the power can be brought at the front. Divide both sides by natural log 2. And natural log 5 divided by 2. 2.322, because I'm rounding to 3 places. 2.322. 2.322 approximately. And no, we knew that it was between 2 and 3. Has to be correct. Okay, another example. This one's slightly different. In front of the exponent, there's an 8. It's 8 times 3 to the power of x equals 5. Keep in mind that 8 is not raised to the power of x. It's just 3 raised to the power of x, so base is 3. And we're trying to get to x, so I'm going to first get rid of the 8 from both sides, and clearly they're being multiplied, so the easiest way is divide both sides by 8. 3 to the power of x equals 5 over 8. Now this is ready to take the natural log on both sides. Oh, I forgot to write log. Natural log 5/8. All right. Now take that x, and it can be brought as the product. Natural log of 3 equals 5/8. And divide both sides by natural log 3. X equals natural log 5/8 divided by natural log of 3. From here, calculator can take over, and I should have x. -0.428. -0.428. So this exponent, this exponential has to be negative. Think about it for a second. I'm looking at 3 to some power equals 5/8. Now 3 to the first power is 3. So I'm like, oh, this number x is definitely less than 1. 3 to the power of 0 is, anything to the power of 0 is 1. We have 5/8. So that means our answer is even less than 0, if that made sense. And hence our answer was less than 0, negative power. I will show you one more. This one's slightly longer, but it's a good one. 2 to the power of x minus 1 equals 5 raised to the power of 2x plus 3. It is an exponential equation, right? Okay, if I look at the left-hand side and the right-hand side, they both have completely different bases, right? So I can't really compare apple to apple. However, if it would have been this, let's say 4 raised to the power of 2x plus 3, then I could have made the same bases, because 4 can be written in terms of a base 2. 4 can be written as base 2 raised to the second power. But it's not, so I really can't do any of that stuff. So my only option is to take log or natural log of both sides. That part doesn't matter. And I'll use that same third property. I see a power here, so I'll bring it in the front, x minus 1. and keep that log 2. Same thing here. The exponent is 2x plus 3. I bring it in the front and log 5. From here, I'm going to do a little bit of algebra, which is distributing. So I'll distribute these two. X times log 2 minus just log 2 equals, distribute that, so 2x times log of 5 plus 3 times log of 5. Treat log 5 as an x in algebra. Now, if you look at this term and this term, they both have x's in them, and they're both on the other side. So I'm going to bring those two terms together on one side. I can do that simply by subtracting 2x log 5 from here and subtracting 2x log 5 from there. This cancels. And at the same time, a log 2 and 3 log 5, they're similar terms because but both don't have x's in them. So I'm going to get rid of the log 2 from here by adding, right? Because this is subtraction, so only adding can take care of that, plus log 2. So on the right-hand side, I have 3 log 5 plus log of 2. Remember, the base here is automatically 10. If there's no base, then it's automatically 10. I'm undistributing the x from here because x is what I'm trying to find. Right hand side is the same. Again, x is what my goal is, so I need to get rid of all of this. The only way I can get rid of all of that is by dividing by the exact same thing, and I can put all of that over log 2 minus 2 log 5. This basically means 3 times, like this means 3 times log 5. Log 5 has a value, you can find it from the calculator. Add to that log 2, which also has a direct value, which can be found from the calculator. And then divided by the difference of log 2 times minus 2 times log 5. But we can't do it in our head, we'll have to use calculator. The bottom line is I have x on one side and all that on the other side. So it's time to plug it into the calculator very carefully. All I have to do is plug all this in the calculator. Let's do it and we will be done. Open parentheses might be best, or 3 log 5. Yeah, I'll have to open parentheses because all this is numerator. Plus log 2 was also in the numerator. Then I'll close parentheses and I'll close another set of parentheses. Divided by, making sure it takes it correctly, log of 2. Oh, then we had minus 2 log 5 in the denominator. Oh, I forgot the 2. There was a 2 here. 2 log 5. Close parentheses. There we go. So it's negative 2.186. X must equal negative 2.816. Oof, I know that was quite a lot of work. But hopefully the concept is somewhat kind of getting there. And I hope I'll be able to show you more examples in class. So that was it from today. 2 topics. Using the same 3 properties of logs, can we solve log equations and can we solve exponential equations? That's it for now. Have a good one. Bye.